Okay, good day everyone and welcome back to our YouTube channel. Today in physics, we are moving to motion. And what do you know about motion? Basic thing. What comes to your mind when you hear motion? Movement. So what is motion? Motion is the movement or change in position of one object from one point to another. So let's take for example we have a car of this shape moving from point A to B. It has changed It has already changed its position from point A to B. So that is motion. Motion is basically the movement of a object or a particle from one point to another. Okay, so I guess we should already know we should have an idea already about motion. So before we move to types of motion, we have basically two studies under motion. That is dynamics and kinematics. Now looking at dynamics is the study of motion considering the force that is being applied or the cause of the motion. Yeah, dynamics is the study of the motion and the cause. Study of motion and the cause of the motion. Meanwhile, kinematics is study of motion only, without considering the force or cause of the motion. Basically, we all know cause of the motion. Causes of motion, the main cause of motion is force. When you apply force to an object, the object tends to move. So dynamics is now the study of the force and the movement of that particular object. Meanwhile, kinematics is only the study of motion without considering the force under it. So, so you can just take note of dynamics and kinematics. Can come out in your exam. I don't know. So now moving to types of motion, we have different types of motion, but the basic ones is what I'll be explaining. We have linear motion, linear. We have rotatory motion or rotational motion. We have oscillatory motion. We have relative motion. Relative motion. So explaining these basic types of motion, we'll be talking about others later. So linear motion, according to the name, what does linear mean? That is motion on a straight line or motion in a straight direction. That is just that. For example, is movement of a car. It can either be called linear motion or rectilinear motion. So next one is rotational motion. According to his name, rotational. Rotational motion is the motion of a particular object in a circular direction. Yeah, in a circular direction. And an example of this rotational motion is rotation of a fan blade. And note that in a rotational motion, the object moves in a circular direction around a fixed point. For example, if you look at your fan blade, it gives this kind of shape, this kind of shape. So the fan blades move in a circular motion, that is, it is rotating along this fixed point. This particular middle point is not moving. It is only the fan blade that is moving along this fixed point. That is what you know about rotational motion. And then we also have oscillatory motion. Oscillatory motion is basically the periodic to and fro movement of a particular body. Example of oscillation motion can be your simple pendulum bob. We all know the diagram of a pendulum bob. And another example is when you are eating a punching bag. You know, a punching bag, when it's fixed to a particular point, it is going to and fro at a particular fixed point also. So to and fro movement. Yeah. And relative motion. Relative motion is basically the movement of a body relative to another body. Yes, so let's give for example on the road, when you are moving or on an expressway rather, where you have trees, so the car moves relative to the poles or the trees on the particular expressway. So as the car is moving, it is moving relative to the trees or poles on the particular expressway. So in I've talked about this the other time, that the main cause or the major cause of motion is force. When I was explaining dynamics, I said dynamics is the study of motion and the cause of this motion. Now the major cause of motion is force. And now you can also take notes that you can have different kinds of force. We have the contact force and non-contact non-contact force. That is, you can apply a particular force or on an object by making contact with it, and you can also apply force by not making contact with it. So we are going to be looking at examples. Now, examples of contact force, we have pull, push, and we also have frictional force. Frictional force. And we know frictional force to be the force that tends to oppose motion. As a body is moving in this direction, frictional force moves in the other direction. Now, non-contact force, this is basically also known as force field. That's when you have your magnetic force, gravitational force. So this magnetic, gravitational, and electric force. So magnetic force is when you want to move a magnet, a particular magnet, you can magnets can come together without particularly hitting each other. Like, you get what I'm saying? Gravitational force, when you have a force of gravity too, also there's a force or a region of space around it that tends to drag the object downward. So that is it. It does not make contact. But this one, pull and push. If you want to pull a object or you want to push it, you have to hold the objects. So that is it. So I've talked about one of the contact forces, and I make the example that frictional force is an example of a contact force. So we'll just be basically giving you an idea of what friction is. You know what friction is? Friction is the force, or is the frictional force is the force that tends to oppose motion. So let's say we have a body, and then a force is applied on this body. This is applied force, FA, to move this particular body in this direction. Then your frictional force would move in the opposite direction, tending to oppose the motion. So this is direction of your frictional force. Yeah. And then you know the weight of the body acts downward, which is the weight, and your weight is equals to mass times gravity, or acceleration due to gravity. Yes, so we have static friction, we have kinetic or dynamic friction. So we'll just be explaining I'll just be giving you a brief explanation on what this means. Static friction or and kinetic or dynamic friction. Now, static friction is the friction, or is the maximum force. Static frictional force is the maximum force that must be overcome to allow the object to move. So is the maximum force. Let's say, for example, this force, the frictional force on this object is 3 Newton. So static friction on this object is like 3 Newton at rest. Yeah, at rest. So for this object to move, you have to overcome this 3 Newtons for the object to move, just to make the object move. Meanwhile, kinetic friction is the frictional force when the object is already in motion. Kinetic or dynamic friction is the force that must be overcome so that an object can be in uniform speed with another body. So up next, we'll be moving to laws of friction, basic laws of friction. So the first one, friction opposes motion between two surfaces in contact. If you have a wheel car, or the wheel of a car here on the road, so the frictional force opposes the motion between the wheel of the car and the surface of the road. That's just it, within the two surfaces in contact. So the second one is force of friction increases as the force which starts motion increases. So as the force or as the applied force of motion, or the force that is tending to cause the motion, so as the force increases, the frictional force also increases. That's what this second law is just trying to tell us. And this third one, frictional force depends on the nature of two surfaces in contact. So you can have rough surface, you can have smooth surface. So that's when you now see some question that the frictional force on the rough surface, frictional force on the smooth surface. So we'll be looking at that one later. So frictional force depends on the nature of two surfaces in contact. Go. So frictional force, the fourth one, frictional force or friction is independent of the area of surfaces in contact. And the last one, we have frictional force is directly proportional. Looking at this, is directly proportional to the normal reaction. That is, F is directly proportional to R. So F equals to mu r. Mu there is a constant of friction. So up next, we're looking at advantages or application of friction. Don't be confused. Advantages of friction is also known as the application of friction. So the first one is working. Friction makes working possible. So it's the opposing force of motion that allows you to walk or makes walking more easier. Second one, automobile tires make firm grip on the road. It is the friction of the wheel on the road surface that makes the firm grip on the road. What the third one, it allows screw or nail to remain in position. Okay, so up next, disadvantages of friction. Number one, friction causes wear and tear. You can look at some surfaces or some objects that tend to move every time, that tends to undergo friction. Those objects or those surfaces begin to wear and tear off. So the second one, the friction reduces efficiency of machines. Yeah, when you need basically more force to overcome the frictional force, or you need more work to be done to overcome the frictional force, the machines begin to reduce, or the efficiency of the machines begin to reduce. And as the efficiency reduces, it also causes eating on some machines, thereby causing loss or damage to the machines. So we have different methods of reducing friction. First one is your streamlining. Streamlining is a method of making the shape of the object that is in motion, making it like only a small part of that object to come in contact with the surface. Like for example, the streamlined body of aircrafts and all that. So it reduces friction with the fluid, which is air or liquid. Yeah. So another example is ball bearing. Ball bearing is another example of or another method of reducing friction. Shafts are fixed on ball bearing so that friction will be reduced, because rolling friction is less than sliding friction. Also note that. So ball bearing is like putting shafts into some objects to make them, or shafts or ball bearing into some objects to make them undergo rolling friction, because rolling friction is less than sliding friction. So it tends to reduce the friction. So the third one there is polishing. So polishing the surface of objects in contact, yes, can reduce friction. And we also have lubrication, addition of grease and oil to these objects or these surfaces in contact. That one can reduce friction. One of our laws of friction that we have discussed earlier, we said that frictional force is directly proportional to the relative or normal reaction. So note that this R is equals to mg, and m is your mass, your g is acceleration due to gravity, which is normally 10 meter per second square or 9.8 meter per second square. So f, when you remove the proportionality sign, it will be equals to mu r. Mu here is your coefficient of friction. So coefficient of friction will be equals to f over r. Also note that this coefficient of friction has another formula when there is friction on an inclined plane. To get the coefficient of friction on an inclined plane, we have mu equals to tan theta. So we are going to be using these basic formulas to solve calculation questions in frictions. So I would be saying out some questions now, and would be noting them. So and I'll be reading out the questions. We'll be taking one or two questions under calculations in friction. Yeah, that's it. So the first question: calculate the magnitude of force required to just move a 20 kilogram object. M equals to 20 kilograms. So the mass of object is 20 kilograms along a horizontal surface if the frictional force mu is equals to 0.2. Another thing to note here is that frictional, or coefficient of friction rather, if the coefficient of friction is 0.2, another thing to note here is that coefficient of friction does not have any units. So mu equals to 0.2, taking g to be 10 meter per second square. Yeah. So one thing in this question to take note is that they said calculate the amount of force required to just move. Remember when I was explaining static friction, I said it is the force required to just move, or to tend a body into motion, to tend to move a body into motion. So that means we are basically looking for the static friction. Yeah. So that is F. And we know our formula for frictional force, F equals to mu R. So mu equals to, and R also equals to mg. So F equals to, putting R there, you have mu g. So put your equations, or put your parameter rather. So F equals to 20 times 0.2 times 10. So using your calculator, you get 40 Newton. So that means the static friction to just move a 20 kilogram object along a horizontal surface of that has coefficient of friction 0.2 is 40 Newton. Okay, so the second question is a force of 20 Newton, F equals to 20 Newton, applied parallel to the surface of the horizontal table, is just sufficient, note that word, just sufficient, to make the block of mass 4 kg. A force of 20 Newton applied parallel to the surface of a horizontal table is just sufficient to make the block of mass 4 kg move on the table. Now they said calculate the coefficient of friction on that table. So our basic formula, taking g also, equals to 10 meter per second square. So our formula for friction, F equals to mu R. We're looking for the coefficient of friction. So mu equals to F over R. Put in your equation, and don't forget that R equals to mg. Put in your parameters. F is 20 Newton all over R, which is 4 times 10. So that's 20 over 40. So that is 0.5. Note that your coefficient of friction does not have any units. So that is all on our class for today. So learning involves going more to research more, solve more questions, and then if you have any questions, you can ask them in our comment section and we'll be sure to answer you. So thank you for watching.